Let's take a look at some more things that we can do with strings. Here's kind of an overview of some of the things we've already seen that we can do with strings and some things that we'll take a look at further today. There's also a link down here at the bottom to the Python documentation about string methods, so that you can see that there are actually many more methods that belong to strings, as well as what we'll discuss here. So we've already seen indexing, that we can get particular characters from the string by indexing, that we can get portions of the string by slicing, and that we can check the length of the string using the len, L-E-N function. We can add strings together, or in other words, concatenate strings to make longer strings. We'll also see that we can split strings and, in fact, even join things back together into a single string. And we saw that we can manipulate some of the details of the string's characters to make, for instance, new uppercase or lowercase versions. And there are many more methods like those that you can see in the Python documentation. And that we have this mapping between some numbers and characters, that we can use the ordinal function to get the number from a character, or we can use the CHR function, character function, to get a character from a number. Let's dig even further into some of these. One thing that I want to point out here early on is that appending, the append function, works for lists but does not work for strings. And this brings me back to an earlier point when we were talking about strings before. Strings are immutable, unchangeable. The string S here is set to refer to the word hello in quotes. Therefore, it is now a string, and that word cannot be changed itself. Appending would change the actual string stored in memory. Just like for lists, appending changes the list that the variable references. It changes some aspect, some feature of the list that the variable references. We can't append to strings, but we can use plus to create a new string. So we could say hello plus there, and that will create a new string. And remember that plus equals is shorthand for saying here, for example, S equals S plus there. And that will work because it creates a new string, hello there, and then it stores it as S. So hello, the original string, still exists somewhere out there in memory for now. It may go away later, but it's not changed. We built a new string using it. And it's also worth pointing out that when we do indexing on strings, for example, if we said S index 0, we can get that character at index 0, but unlike for lists, we cannot change the entry at index 0. Again, we can create a new string where the entry at index 0 is different than it is in the current version of S, but we cannot change character by character, and many people find this a bit frustrating about strings in Python, that you want to just change one piece about the string, but in fact what you end up having to do is to build a whole new string using the pieces that you want to keep and the pieces that you want to change. So we can use strings as accumulators, for instance. Here, we'll be building the alphabet by starting with character 97, which is lowercase a, and going onward through character 97 plus 1, character 97 plus 2, and so on, out to character 97 plus 25, which would be lowercase z. And so this will start with an empty string. My string, the variable my string, is set originally as the empty string. In the first time through this loop, I will be 0. And so next character becomes the character 97 plus 0, in other words, lowercase a. And my string gets my string plus next character, in other words, empty string plus lowercase a. And then the loop will continue, the character will become b, and the my string will have its current value, just the string containing a, combined with the character b. And so we'll have ab at that point, and it will go on, all the way out through z. And so by the end of this for loop, we'll be printing a string that contains the entire lowercase alphabet. So again, we can use a string as an accumulator by starting off with an empty string, or starting off with some string that we know we want at the start of our accumulator, and then adding on at each time through a loop or each step of our code. We saw that we can do slicing in strings, just like we could do slicing in lists. And it's worth taking a moment to look at some other ways that we can do slicing. So you've seen the slicing where we give a start index and an end index. You can also give a value for how much the step will be between items. So for instance, this example given here where we say 1:9:3, this will get characters between 1 and 9, but it will skip 3 indexes each time. So it will get character at index 1, in other words, the 2 here. Then it will skip to index 4, 1, 2, 3, and get the number 6. And then it will, I think that's right, 1, 2, 3, 4. No, we'll get the number 5. And then it will skip 3 from there again, and it will get the number 8, and so on, all the way out to ending at character 9. So it will not include the character at index 9, but it can include up to there. And it will step by 3s. So this is just the same as the one above, except for it has fewer characters because it doesn't step from index 1 to index 2 to index 3. It skips forward by 3s. So it gets every third character, starting at index 1. Here, we actually get, and that one ended at index 9. This one will go all the way out to the length of the string. So it will get all characters between 1 onward with a step of 3. So it will get every third character, starting at index 1 and ending at the end of the string. The one shown below actually does the same thing because you'll remember that not including a second value, not including an end value, means go all the way to the end of the string. Here we are getting the character at length -1, and we get sort of shorthand that we saw before for lists by just using -1 as the index to get the last character. And I wanted to remind you that you can do that with strings as well. Here are some examples of strings that vary a little bit in sort of what they contain and what their characters are like in terms of features. And we have many different functions, many different methods with strings to ask questions about the features of that string. For example, if I were to say myString.isAlpha, I would get true as a result, because isAlpha asks the question about the string that comes before the dot. Does that string contain only letters? So if I asked myPass.isAlpha, or rather if I called myPass.isAlpha, the result would be false because myPass has some numbers in it. It's not all alphabetical characters. Likewise, myPass.isDigit would return false as well. There are some digits, some numbers in my string there, but there are also some characters that are not digits. If I asked myString.isAlnum, or is alphanumeric is what that stands for, then I would get true. In fact, I would get true for myString, myPstring, or myPass.isAlnum, because all of those contain some combinations of alphabetical characters and or numbers. But I would get false for myHash.isAlnum because it has a $sign character in it, which is neither an alphabetical character nor a numerical character. And then I can also ask if a string is all uppercase characters or all lowercase characters by calling isUpper. So myString.isUpper would return true, while myString.isLower would return false. And vice versa, my pstring has a combination of upper and lowercase characters, and therefore it would fail both of those checks. It would give false if I called my pstring.isUpper. That's false. It's not all uppercase. And my pstring.isLower would also return false because it is not all lowercase. And you can try out those different tests and see different features. They can be very helpful in if statements or the conditions for loops to test certain things about the strings that you're seeing. We can ask strings for modified versions of themselves, which we saw with the .upper and .lower functions, that I can ask a string to give me a version of itself that is all uppercase or a version of itself that is all lowercase. There are many more ways to get modified versions of strings, and here are a few functions that you can call to get new versions of strings with some of the white space around them removed. It will be quite common that you might want to get rid of any spaces that the user typed before their input to you, or spaces or return characters or things like that that they might have typed after the value that they want to give to you. And so you can use the strip functions, the strip methods on those strings. For instance, if I took my string here, which starts with a little white space, a few spaces, and ends with a little white space, if I called myString.lstrip, that will return a new version of the string where all of the spaces on the left are removed, the spaces in the middle are untouched, and the spaces on the right-hand side are untouched if I use lstrip. So that would be if I called myString.lstrip. If I call myString.rstrip, then I would keep the spaces on the left, I would keep the spaces in between words, but I would lose the spaces on the right-hand side. And then myString.strip would remove white space from both ends. The right-hand side and the left-hand side of the string here would lose their spaces. Spaces in the middle are again left untouched. And I want to reiterate, these will not change my string, the variable there. If I call mystring.lstrip, mystring.rstrip, and mystring.strip, the original mystring will not change because strings are immutable. I will get new versions of that string that have different features to them. And so I would want to make sure that I saved that in some variable. I could either save them as mystring and change what mystring is talking about and naming, or I could save them as some new version, stripped string, or something like that. Two other really powerful methods that we'll use are split and join. You'll use these quite often when you're taking input from files or input from users. So here, for instance, we have new text, which is the sentence, "We are who we are." If we want to split up all of the words, or in other words, split on all spacing, then we call newText.split. That gives us a new thing that is a list of strings. So we now get a list of strings containing all of the words in that original string. This is something you'll frequently do when you're separating first names and last names, or you're counting the number of occurrences of a particular word, or any time that you might have items separated by white space. Then just plain old split will get the job done for you. You'll also notice that it removes the character that it split on. So it split on the spaces, and we get we, the string we, with no space, the string are with no spaces on either side of it, and so on. So whatever we are splitting on gets removed, which it's worth noting, we do not have to split on spaces. We can call split with a string that will be the thing that we split on. You could split on the word the in your sentences to see what you say on either side of the word the. Lots of different things you could possibly split on. Here, for instance, we see an example where someone did it wrong at first. They wanted to split this date that had decimal places between each of the, or had periods between each of the month, day, and year. But they called split, and split by default splits on white space. So what they would get from this split is a list that contains only the original string. It won't get broken up in any way into multiple strings. But if I call split with quote, period, end quote, that tells split, look for periods in the text that I'm splitting, and eliminate those periods and create new strings on either side of those periods. So from this one, we would come away with a list that contains the string 10, another string 10, and the string 2016. Because we told it explicitly to split on the periods, again, they'll be removed entirely. They won't appear in the list anywhere. When we have split up strings, or when we have lists of strings, we can put them back together, or put them together for the first time, using the join method. The join method is a little tricky conceptually, because for many programmers, myself included, you often think about what is the stuff you're joining together. So for example, if I have a list of strings, I might want to say stringlist.join. That would be incorrect. What you join with is called the join string. It is the thing that will go in between the strings that you are joining from the list. So here, for instance, we are putting a space in between each element from string list. So if you look at this whole example, we take my string, which is a sentence. We split on spaces because we split with the default. We didn't specify any split characters, so it defaults to spaces. We'll get a list that contains the string U and the string found and the string A and so on. We called that string list, and we then used space to join all of the elements in string list. So it will take the string U, add a space in the middle, and add on the string found, then add a space and add on the string A, and so on. So we tell it, what would you like to go in the middle? Then you say dot join, and inside the parentheses as a parameter, you provide the list of strings that you want all of them to be joined together. On the other hand, if, for instance, so the original example recreated the string my string, essentially, because it put the spaces back in and joined everybody together. On the other hand, I could provide other things to go in the middle. So essentially, this bottom example where I say quote dash dash end quote dot join string list inside of the parentheses, that will replace all of the spaces with double dashes. So it would say U and then put a double dash as the join character, and then found, and then a double dash, and then A, and so on to rebuild the string, but with these dashes in place of where the spaces were in the original string. I pointed out before that strings can be looped over. This is because strings are sequences, and sequences like ranges or lists or the keys in a dictionary or the values in a dictionary are things that can be iterated over, looped over. So, for example, much like we saw before, if I say for C in some string, it will go through each character in that string. So here I'm saying if my character is the letter A, or if my character is the letter E, or if my character is the letter I, etc., basically checking if it is a vowel. If it is a vowel, I add it to my accumulator. So this will look through the string lucky sandwich, and it will keep only the vowels from it, only U, Y, A, I from that original string. And then it prints out the resulting accumulator at the end. So this loops over every character in the string. We could have simplified that code, by the way, because we can do containment with strings. We can check for containment, just like we did for lists. So we can say if C is in the string A, E, I, O, U, Y, then add it to our accumulator. That's a much shorter version than the one that we did before, where we explicitly checked if C was A, if C was E, and so on. Now, those previous examples looped over single characters. Many beginning programmers get it wrong when they want to loop over the words in a sentence or in a string. So when you want to loop over the words, you need to split the string into a list. Because if you just say for I in my string, you'll get every single character from your string. You won't get words, you'll get characters. And that will function, and often your program will run just fine, but you'll come out saying that Shakespeare never used the word the, because no single character will be equal to the word the if you were searching for it by looping through all of the you thought words, but actually you were looping through all of the characters in A Midsummer Night's Dream or something like that. So instead, we take my string here and we call split to create a list, which we've called split string. And then we can say for I in split string, or often I will say for word in split string. And then you could print out the lengths of the words or check if the word is equal to the, or any number of other things that you want to do with them. So let's bring some of these ideas together, and we may get some time to look at these examples in class and think deeper about what they are doing. But here I've defined the string my other pet to be Polly the cat. And if I say my other pet dot upper, stop and think about it just there. That creates an all uppercase version of Polly the cat. So capital P, capital O, capital L, and so on. So that on its own could be a complete statement. It results in a string. Because it results in a string, I can then call other methods using it. So this will get the result of calling upper, and then it will split. It will split into a list that is all uppercase Polly, all uppercase the, and all uppercase cat. So we can sort of put these together to do multiple operations on one line. Likewise here, I've said my other pet, and I've sliced from index 0 to 10. 0 is the default if I don't provide an original starting value. So it takes from characters 0 through 10, not including character 10, and it splits it on spaces again because I haven't specified anything for the split character, so it defaults to a space. So this would again create me a list, but it would be a shorter list because it wouldn't include the last word there, just Polly the. So it would be worth taking some time to think about the ways that you could take a string like Polly the cat and turn it into, for instance, only the all uppercase word Polly. There's more than one way to generate that. For example, you can split to get the first word. Then what do? Getting Polly the cat as a list. Again, there are multiple ways we can do it. Some are cleaner and simpler and probably faster than others. You can even get the string repeated twice, Polly the cat, Polly the cat. Think about how you could structure things to get that. Or even more interestingly, have the first version of it be all uppercased and the second version of it be all lowercased. So these are a bit arbitrary as examples, but they may get you started to thinking about the ways that you can take an existing string and manipulate it and start to change it and get what you want out of it, like getting the first name of a person who provided their full name, or getting the different words from that string to be able to then do some analysis of them. How frequently does this person use words that indicate anger, for instance, or things like that? So there are many, many interesting and useful things you can do with strings, and Python provides really powerful operations and really powerful methods for manipulating, examining, and processing strings.